So today I've got my Oxford FloodNet hat on. It's not my normal hat. My other hat is MLL Telecom doing broadband networks, and in fact my other hat is my company Lovehertz, which was founded sometime last year after my last Whitespace talk. So this is actually less about Whitespace perhaps this time, more about an answer to the blank looks that people gave me when I said sensor networks. People would say, what's a sensor network? Why would you do Whitespace? What is it? What do you want to do with it? And I came up with an example of a network, a guerrilla sensor network. It was something that you deploy yourself using license-exempt spectrum, put out sensor devices, and monitor something. It seemed to register with a few people. In the end, the Oxford Flood Network registered with most people. So I'll explain a little bit about what it is later. Before I move on, there are a lot of smart asses in the room, of course, me included, and someone will inevitably tell me that this has already been done. The Internet of Things is the new name for it. This is the old name for it, which was Coke machines on the Internet in the 70s attached to PDPs, and you could finger them and find out how many... does anyone not know what fingering here is? Just realised what I've said. You could use a program called Finger and find out how many Coke cans were left in the machine over the Internet. If anyone remembers Big Fun on the Internet with Uncle Bert, that's pretty much how I discovered what the Internet was back before Twitter and those days. So now we call it the Internet of Things. Or at least Charlie doesn't call it that because he hates the name. It's hard to put into words what it is because it already exists. The machine-to-machine communication, it's devices talking to each other, not people. So equipment such as sensors, small thermostats, the Nest thermostat is an example of that. There are literally hundreds, and now I can't remember any of them, but there are thousands and thousands of devices coming which will be attached to the Internet in some way, probably using IPv4, sadly, but they are coming, and they are going to be just a trickle individually from a data point of view, but 50 billion of them does tend to make rather an impact on our networks, I think. So you may not think it matters particularly to you, it's just more traffic. I think it's going to be quite a lot more traffic. And there are also new models of charging, and I don't know if anyone's heard the phrase over-the-top services, which is what we call the Internet, but to mobile operators they call over-the-top services, and they wonder how they can charge for them. I think this could become like that for the Internet, that you see all this traffic going across it, how are you going to make any money out of it? And considering we do a lot of access, and we reach all the way down to the customers, I think we need to know more about the access technologies that all the sensors are going to use to connect to the Internet. And there's a lot of them. I don't suspect they'll all live on in the same way that we don't all use Sonnet anymore, or HPPI, or whatever it was called. Zigbee, weightless, Wi-Fi, Bluetooth, Sigfox, 802.11af, Z-Wave, N-Ocean, all joined Bluetooth Low Energy, and LAP. So I didn't say interoperability. And that is part of the problem, actually, that they aren't interoperable. But if you go further up the stack, we've got this thing called IP. And IP is interoperable, as far as I know, unless it's version 6 and version 4. We're going to need to bring these together so that people can build applications out of all this. Now, you might still be wondering what the hell I'm talking about. This little chap here, isn't he cute? The dog. That's Nat Morris over here, and that's his dog Toby. And that behind him is a dog treat feeding machine attached to Twitter. And all you have to do is visit Feed Toby and tweet something, I'm not sure what, and it'll feed, that's it, you tweet feed to him, and it'll drop a bunch of dog pellets. What do you call them? That's like slug pellets, isn't it? Dog food. Bunch of dog food to him, and take a photo and post it back to Twitter. So this is the high-tech cutting edge of the Internet of Things. Yes, he is rather embarrassed over there, but that's fine. So this is genuinely something using hardware and physical manifestations, the real world. You can't get much more real world than a dog, and it's connected to the internet in a way that people can really interact with. If I go back to the Gorilla Sensor networks, the Safecast network in Japan. Now, this map here is actually of the Fukushima region in Japan. That is a radiation map made by Geiger counters that are attached to the internet. And they were put out there by citizens, people who actually cared about whether the radiation readings that the government were giving them was accurate or not. This wasn't done by one big organisation. This is a group effort to come and produce real evidence of a real problem. This is my slightly smaller take on it. This is the Oxford Flood Network. So instead of putting your Geiger counter out there, you can build a small, inexpensive sensor using ultrasound rangefinders, just like your estate agent might use to measure the width of your room. And then connect those back to the internet and actually build a map of flooding in a place like Oxford. Oxford does have a flooding problem. It's not an Aston Martin, by the way. So how might you do this and do it cheaply? So the Environment Agency do this already, but they get to dig a big hole by the side of a river, and they fill it with concrete, and they put a big green cabin on the top, and they buy some GSM modems or some landlines, and then they dangle a weight into some water and a float on the other end, a rotary encoder, and it tells you how high the water level is. And they have a rodent-proof pipe as well into the actual river. So they don't even measure it in the river. So they can only build so many of these. I'm looking at something that you can build at really high resolution, lots and lots of readings. And the ultrasound rangefinder seems to be the thing that looks like the best option at the moment. But this is one of many types of sensor. So it would ping the water, it would come back, read the distance, and then send it onto the internet. Couldn't get much simpler, really. The benefit over the Environment Agency is that the bridges, you can stick it under bridges, you can put it in the floor voids, you can ask pubs to host it, so you can go around visiting the pubs and find out if they'll host a sensor for you. That's my excuse. The Internet of Things stack, once you actually put this into context, this is really, the sensor is the bottom one there. That's actually all that represents. Then you've got the rest of it, and that's the bit that probably matters to us, is you've got a device, it's not necessarily clever enough to have an IP stack. It's, like I said, lots of small, stupid devices with IP stacks, probably IPv4 for some time. You need a gateway to connect it onto an IP stack. Maybe your sensor is attached with IP, that can happen. But every bit you send is a bit towards death because of batteries. So having no mains power in these locations is actually a big consideration, especially with radio. In reality, this is what the stack will look like. There'll be thousands of sensors, a few gateways, there'll be a database or several databases, an API, and then you can build your applications on top of that. So you might have a web app on top of that, you might have a mobile phone app, or you might have nothing at all. This might feed through to another data store. So my aim is that the Oxford Flood Network is actually is open data, so that you will be able to build on this. Typically, your technology stack is made up of a sensor made up of an Arduino. Who's heard of Arduinos? Okay, that's good. So for those who don't know, the small microcontroller, much more cut down than a microprocessor, sort of thing that would run your washing machine. Not an internet washing machine, by the way, I hasten to add. They control a few pins of electronics, they control a few sensors, and they can send some data. The gateway would be something like a Raspberry Pi or something that has an IP stack on it. It's a small Unix system, a bit of embedded Linux or something like that, that can then format the messages and send them, deduplicate them, that kind of thing. And then you'd have a database such as Xively or COSM, Open Sensors or ThingWorks if you're looking at the big end of the scale. And that database would be able to store data streams. Now, a lot of you in this room will probably wonder why this is new, because we've been storing thousands and millions of data points every few minutes across all of our networks. I mean, the right probes are an example of that. This is really just telemetry data. So again, it's nothing new. If you package it up with a name like Xively, everyone thinks, brilliant, this is the future. So I don't think it's beyond us to get involved here. It depends what level of network operator that we consider ourselves. You can build the API on top of that. This is quite often domain specific, so flooding or radiation or farming or irrigation, all sorts of possible things. And then the application tends to come on top of that as another vertical, if you like. So how did we build ours? This is version 1. There's a lot of wires hanging out. It does look a little bit like a bomb when you attach it to a bridge. It's not quite the look you're going for when you're doing a guerrilla sensor network. The radio is really that kind of size. It's got a microcontroller on it, the thing in the diamond-shaped thing at the bottom. That is actually an Arduino, effectively, with a radio. So the rest of it is mostly just padding, and it was the first box that came to hand. When I show you version 2, that is a printed circuit board that just takes room enough. Actually, the battery is the problem. The battery is bigger than we need the whole thing to be. The rangefinder's on the back side. You drill a hole in a box, stick it to a bridge, which is easier said than done. What's the bridge made of? How are you going to attach a plastic thing to a metal thing or a wooden thing or a concrete thing? It's actually it's not my strong point, is attaching things to things. Let's put it that way. We use magnets in the end, which make a fantastic way of shielding RF communications. So the hardware is hard, as they say. So yeah, this high energy battery, it's just what we needed. It's not necessarily useful to everyone. You can't send them through the post. You actually have to send them by courier. But this is a step towards something that anyone could build. And the schematics are open source, and the software for the microcontroller is open source. And there is a GitHub page with all this on. There's a mixture of schematics and instructions. But it's something that you could potentially build yourself. Of course, if you don't want to build it yourself, there's people like me, or me specifically, who can build these for you. And that's really what the aim of this is that people can build this themselves. I give them the reference implementation of it. But the design of the whole project is to actually allow people to build it again and again without having a techie in-house, that actually can deploy these and self-fund them so that essentially I don't end up paying for all the hardware. And I think that's an important step in an open source project is if you are still at the center of it all, and the problem is with hardware is that you can't copy it, you can't just give someone another version of it, another a brand new copy of it, then you become the center of the project and the bottleneck. So this is something with easily reproducible hardware. And that's why we've got a Raspberry Pi involved. It's a Linux system. It's overkill, but it's easy. It's got another one of those radios on the top. It's got the internet's over on one side, and it's got that wire antenna sticking out the top. And that's it. That's all you need. And a bit of software. This is probably overkill as well. Node-RED. Who likes Node.js? Or a lot fewer hands now. Node.js is the new hotness in JavaScript and development, and to be honest, I don't know what I'm talking about. It's Node-RED, from my point of view, is a graphical programming language that you just stick a node in there. So that one on the left is serial. You drag it across to a function that passes the bits, the sections of it, and turns it into messages. And you spew one out to a CSV file, one out to debug, and one out to a back-end database. And you can store data streams that way. The one we've got for the flood network gateways sends a message to Twitter. Yeah, it's that easy. You authenticate with Twitter, it pushes it out. So, yeah, arrowheads haven't worked very successfully. If you assume at the end of those sticks are arrowheads, this is where where it all gets a bit sticky. And this is also where the Whitespace comes in, for those of you who are wondering. Whitespace spectrum is interesting if you look at how these things are done today. So the radios that I keep pointing out on the gateway and the sensor device use tiny little bits of spectrum called ISM bands, so in instrumentation, scientific, and medical. This diagram here is the spectrum, the UK spectrum, as portrayed by the American spectrum, because they have a better diagram. Over here, on the left and a little bit on the right, two tiny slivers of spectrum that we get to use for free, aren't they generous, called ISM band. And Wi-Fi is another one of those, 2.4 and 5 gigahertz. And we're all crammed into those tiny little spaces, and we're all using it, and it's working fairly effectively at the moment. But given that there are something like 50 billion devices, apparently, coming, I don't think that's enough space, particularly. The other arrowhead missing was pointing at the TV band, which is that big yellow blob there. And that TV band isn't used everywhere. Now, I've gone over this last year, but for those of you who haven't seen this, TV Whitespace allows you to take a lump of that, so a TV channel effectively, and then use it for your own purposes as long as it's available based on the location you're in. So your device checks where it is, sends a request to the database and says, what spectrum can I use? Gets an answer back from the database, and then if it's a good answer, that is, it starts using the spectrum in that area at that particular power, so it doesn't interfere with anything. Now, that is a much more efficient way of allocating spectrum than, say, an auction. It's something like 3 months quicker, as in it happens instantaneously. You have to check every 15 minutes to make sure it's available still, and you have to be connected to the internet, which is a gotcha if you're doing it from somewhere where there's no internet. But, I mean, where doesn't have internet these days apart from a conference with bad Wi-Fi? But not this one. It's usually they're awful. So yeah, that's TV Whitespace. This is how we're using it. So the sensor gateways work by plugging into broadband. But if you don't have broadband, what you can do is actually plug them into a Whitespace radio that looks a bit like that. It's a bit bigger than I'd claimed it would be last year. The hardware has taken some time to develop. It was supposed to be the size of the microcontroller that you saw earlier. But that's fine. This is development of a wireless ecosystem takes time. What we've done, and with some help from MLL Telecom, we're going to put the Whitespace radio in the middle and point out to the sensor devices. They're going to be attached to the internet over Whitespace, and then hop on from there using that ISM band, which is much shorter range. So that then makes the gateways attach effectively over Ethernet. But this really gives you the answer of what is the sensor network and why would you use Whitespace for it. Unfortunately, because of the size of the radios, we can't go directly to the devices. We have to go via one of these, or the device has to have mains power, which kind of defeats the object of it. So rather than give up and just throw your hands up in the air and say we're not going to do this, you can at least learn something about Whitespace in the process. So what are we actually going to do with this? Well, what we are going to do is build the flood network. We have a couple of prototype sensors out there at the moment. This is an example of, say, 20 or so, deployed in various places around Oxford. This is what we're looking to do. It's going to take, it's all been self-funded up till now. It's going to take some people who know about attaching things to things, people who know about radio, people who know about databases and data stores, and it's going to need organisation as well. And the end result should be a blueprint for how to make one of these for your city or your location that doesn't involve phoning me up and asking me if you can use my database or something like that. This is supposed to be gathering evidence for your community, much like the Geiger counter Safecast network. You're actually gathering evidence for your own problems that you can use to present to authorities who perhaps have a different view of it. Because after all, data has an agenda. It comes with an agenda already. So why not put your own agenda on it by collecting it yourself? And that's where you'll find all the information on how to reach it. We're active on Twitter. There's a Google group you can email. It's moderated, so just wait till you get accepted. And GitHub. Join in the fun on GitHub. Ideally, we'd like to move up the stack a bit and start developing the database parts of it as well. But the any help down at the bottom in the radio and attaching things part would be greatly appreciated. Thank you.
Thank you, Ben. So I have one question which comes from the IRC room, so I don't know how serious it is, but there was considerable interest in what is it that's holding the Ethernet cable on?
The Ethernet cable?
Yeah, on the sensor box, I think it was.
There. Is that it? No, that's
No, I think it was an earlier box.
Okay. There is no Ethernet cable apart from that.
Oh, well.
It's all magic and wireless. That's just bubble wrap.
Okay, so any serious questions? I see Adrian first. Can we mix up the mic?
Brilliant. Hi, Adrian again. What sort of cost are the sensor boxes, and what sort of battery life do they have in operation?
We've got the sensor boxes without the actual plastic box down to about £17. The sensors, the ultrasound sensors they vary in quality. So it may be that we need a £50 sensor to do the ultrasound. That is only one kind of sensor, and if you could do a depth gauge at the end of your garden, that would probably work as well. So step one is just get a sensor working and churning out some data. Step two is really put some more types of sensors out there. But we're looking for something that can be done for £20, £30, something like that. The gateway, Raspberry Pis are 25 quid a go. They don't tend to change in price, but you can have multiple sensors to one gateway.
And how long does the battery last in those sensors?
The battery, we don't know yet. It's still exactly the same as it was when we put it in. It hasn't dropped in voltage at all. We're guessing months and months. Ideally, years, but we don't know.
Okay. I was just thinking while you were describing all this, back to my days when I used to work for Nokia, and you can get mobile phones that have standby times of weeks that are hardware that would do this everything but the sensor. I don't suppose there are any platforms like that could use a common sort of network device like a really cheap mobile phone that could be wired up, that could be used to do telemetry. And if it only turned on once a day, it probably too would have a battery life of years.
Yeah, that's true, if it only turned on once a day, but we need real-time readings of these, so they poll every 5 minutes. And they could be communicated in two directions. At the moment it's unidirectional, they just keep telling us stuff. But if we told them there's rainfall in your catchment using rain radar data, they could increase their polling cycle ahead of time to avoid flash floods. So I think there's a trade-off somewhere between being too sleepy and actually being eating all your battery straight away. But yeah, definitely, it really depends on the cost of the hardware.
Okay, good. Three questions at the back there.
Rob Golding. Are there any real dangers? I mean, telling people in advance that a flood's coming is absolutely fine, but hanging stuff under bridges, on the other hand, is not necessarily as safe as it could be. Having things, obviously, with electricity in them and water, not necessarily as safe as it could be as well. Are there any real dangers in addition to that where the data can't be trusted? If those ultrasound sensors vary in quality and it says there's 3 meters between the sensor and the water, firstly, how high up is the sensor? How does it know? And secondly, if that's 3 centimetres, not 3 metres, are you in danger of telling people to go down a road which is flooded?
Yes. So yes to all of it. So an example in the Safecast network was a Geiger counter in Tokyo that suddenly went red, and everyone went, "Holy crap, we're all going to die." And someone on a message board said, "Is there any water in your sensor?" And yes, fair enough, there was water in the sensor, and that caused it to give an unusually high reading. The fact that there were so many other sensors around it showed that that was an outlier, which meant that you could investigate it, but you wouldn't necessarily take it seriously. So you can filter some of those out, or you can, it depends how consumer-facing it is. If it's early stages, you know to ignore the outliers. Safety-wise, this is 3 volts. The only thing that might get harmed is fish, very small fish, water boatmen maybe. Having said that, that high-power lithium battery and water probably don't mix too well. So that's why I'm not particularly happy about that battery, but you know, there are options. And also drowning when you're fitting the sensor and getting duck shit on your jeans as well.
I mean, from a, you know if it's flooded, because when you come downstairs, your carpet goes squish. Would 2 wires and knowing that the water level is 3 meters below your house and sticking a sensor in that simply gets, if it's got a current, shit, the water's coming, not be just simpler?
It's not so much the it's not so much the sensor itself, it's the mechanism to get that back to the internet. So the sensor is almost a platform. The transducer that's actually doing the readings is attached to a sensor. That could be a stick with some contacts on it. It could be an inundation sensor under your floorboards. It's a small, reproducible device that will send very small packets of information.
Okay, so next along.
Hi, Tim Thornton from Accenture. So if I could make a couple of comments regarding Adrian's question first, and then a question to you. In terms of mobile phones for these applications, there are some applications where the cost of that, both in terms of the battery and the platform, is just too great. So waitlist spec is looking to be able to produce at volume devices that have a 10-year battery life at about $5 per unit. And crucially, compared to GSM, much higher densities per base station. Newell has been the company that's been leading the waitlist alliance. But over the past year, they've done a big volte-face about the use of Whitespace for it. And my question is, have you seen any impact of Newell's decision to move out of at least the main Whitespace bands in terms of the wider TV Whitespace environment?
I think it's hard to say whether it's just perceived or whether it's genuine. The feeling that maybe we've been abandoned and Whitespace wasn't that important to Newell. I think Newell have publicly said TV Whitespace isn't any good for the Internet of Things. What they didn't add was for our business model, which is we want to make a big exit. How are we going to do that with license-exempt spectrum? We're not. How are we going to do it by selling it to a telco? That's how we do it. So that's slightly caveated what they've said. Whether they have actually test data that says that you can't use TV Whitespace for weightless, they're going to be the ones who know that. They are using TV Whitespace for uplink or downlink, but not both. And they, I think, partly do that just to show that you don't need to use TV Whitespace, that you can use another band. So it would be dangerous to follow exactly what Newell are doing, even though we'd all kind of based our plans on what they claimed was going to be possible, which is exactly what you said, 10 years on a single battery. More like 10 years waiting for that to happen, which is why we've ended up with that size of radio.
Okay, so there was one more question at the back. Martin.
Martin Levy, inevitable question. Internet of Things and IPv6, these are two buzzword bingo names that go together, but outside of your earlier comment, which was very quick, can you sort of actually talk about this issue? Because normally we think of IPv6 as being the savior for Internet of Things, every refrigerator needing an IP address, etc. But seriously, as you've grown this, talk about your IP deployment and what you did with that, please.
The IP deployment is using the broadband IP address of wherever the gateway is hosted. That is a well-known ISP in this room that could support IPv6. Now, because my own experience is that I wanted to get it up and running using IPv4 first, I suspect that further down the line, less network experienced people will also try and do that. They will immediately hit the problem of being behind NAT. They'll start to solve the problem by breaking out through NAT and finding a place to rendezvous. So I think 6LoWPAN is admirable in that it intends to solve that problem by starting natively IPv6. It has detractors. I'm not quite sure why. I suspect because it's not implemented that often. In answer to why I haven't used IPv6, it's exactly the same reason I suspect no one else will in the beginning, because they don't have the time to find it out because they're too busy under a bridge. I absolutely know that I should, and I will need to make it scale.
And I'm just looking, everything's on GitHub, so from that point of view, others can provide you the assistance necessary.
That would be nice, actually. That would be excellent.
All right, thanks.
Okay, we had three, I think we've got four more people who want to ask questions now, but we're into break time. Do people want coffee or do they want to hear more questions? Okay, there was one in the middle here, and then Neil. Okay.
Stewart from Arista Networks.
Hang on for the microphone.
Sorry. Stewart from Arista Networks. You Have you engaged the Oxford and Reading hack spaces in these projects already?
Yeah.
I was going to say, if not, they've already been doing lots of small-scale wireless and those kind of projects.
Yeah, I haven't approached Reading Hackspace. Oxford Hackspace I'm a member of, and I've done a few sensor workshops there. Happy to do more if anyone wants to come along and build some sensors or learn how to do it.
The other thing I was going to say was that if you're going to the effort of building these sensors, it makes a lot of sense to collect things that are easy to collect that you don't know you have any use for. So you might want to measure soil pH or the wind speed or the lifetime of your own battery, because that kind of data collection long term, if you can measure your current consumption and the degradation of a lithium cell, someone somewhere will want to know how long does a lithium cell last if I draw 10 microamps.
Yeah, that's a very good point, actually. One of the things you have to do, which we didn't expect was necessary, was to collect the temperature to compensate for the speed of sound in different temperatures, because it changes the distance.
Humidity as well, I imagine.
I should imagine so. We'd have to drill another hole in the box.
Okay, and then Neil was next, and then Ray.
Just two things to consider really that might help in terms of the manufacturer. So I used to race model cars, and there's a bunch of sensors on one of the control units that's really low power, and also optimized so that when the power gets low, it kind of manages it quite well. A company called Spectrum, and they actually operate on the ISM band, and I think you might be able to jury-rig that to act as a sensor, and it will transmit out. And then the other part of that is lithium polymer batteries, which are used in boat racing, radio-controlled boat racing, and have more waterproof help. Not much more, but a little bit more. And those guys tend to have a lot of detail about how long batteries last. Because you're in a race, and if your battery dies midway through, you're in trouble, obviously. So it might be worth, if there's a model shop nearby, having a chat with those guys.
Yeah, that's a good idea, actually. Yeah, definitely waterproofing lithium batteries is a good one.
Yeah. Okay, so then we had Ray, and I think there was one more in the. Okay. Do you still want to ask a question? Yeah.
Yes, sorry for my English, I'm not local. I have three questions. First of all, I'm impressed about your project, but I also invented the same project after being hit by the flood in Maidstone this year. So when did you start your project?
I wanted to start it last year. I ended up just having to start it because flooding was happening, and it was the time to get help. So it was during the floods.
Yeah, also I found a couple of missing bits when I was inventing the same thing. So what's the distance between the sensor and the station?
With a big metal girder in the way, about 10 meters. If we can change that to be a ground plane, that could improve. If we could use an external antenna, that can improve. But the claim is 100 to 200 meters.
Yeah, okay, and the last question. Do you need a council permit to put the boxes under the bridges, or do you just put the boxes?
Depends on the ownership of the location. Sometimes it's easier to apologise than ask for permission.
I'll be...
Not that UKNOF condones any of these things. If you find people who are engaged with the problem, they become the curator of the sensor, if you like. We've had suggestions that you might be able to turn it even into a kind of a Tamagotchi thing, where they nurture the sensor, make sure it's operating properly. They have different personalities because they are different types of sensor.
My initial idea was to ask for companies like BT or anyone else for the sponsorship of the line with the DSL to every bridge that I want to measure at the bottom of, and I can feed the equipment from the voltage that present on the line, and also I can use that in DSL transmission. Did you try to look for the sponsor?
I have looked for a sponsor. In answer to the question of the copper lines, I was under the impression you could only get a copper line to someone that had a postcode, but I'm not sure if that's just a myth. It's a street access product. Okay, so you could potentially do that. There were some sharp intakes of breath about whether it was allowed. Funding-wise, we've put in an application to Nominate Trust, which is the profit part of the non-profit of Nominate, to do it as a social technology innovation that it focused more on the fact that it's something that could be reproduced for communities to help themselves.
Okay, thank you, and I would like to participate in your project because
Fantastic,
I'm technically quite normal there.
Okay,
thank you.
Okay, thank you for all these interesting questions, and thank you, Ben, for fielding all of these interesting questions and your talk.
Thanks for the curiosity, I'm surprising.